Very good morning to my beloved panel, so Dr. Nur Shahida binti Muhammad Shah and also technologist Muhammad Fadli bin Abdul Razak. My name is Farina Tasa binti Zakri and my project entitled Development of Ground System Terminal for Nano-scale Satellite. The supervisor who always helped me to finish my project is technologist Dr. Muhammad Azri Muhammad Lui. I want to thank to him because he always helped me to encourage me and help me to finish this project. Next, we move to the objectives. Right. The objectives of this project it is to study the system involved in the nanoscale satellite and to develop a ground system terminal at an affordable cost. Besides, it also to collect and analyze the data received from nanoscale satellite every 5-second interval. That is the objectives of this project. We move to the background of this study. Alright, as you can see in the figure 1, it is show the block diagram of ground system terminal, right? It will start at the payload microcontroller first before the data is transferred to the transmitter, and then next from the transmitter it will receive by the antenna and receive by the telemetry, and the USB adapter will save the data in the laptop. Laptop itself is right, as you can see the background of the study in the figure 1, it shows the block diagram of ground system terminal where it starts from the payload microcontroller. From the payload microcontroller, it will collect the data of the telemetry data and it will transmit the data to the transmitter and receive by the antenna. And next, it will pass to the telemetry and to the adapter, USB adapter, where the USB adapter will save the data there, and the laptop acts as a ground system terminal where it will show the data by using the GUI interface, and the human will conduct the ground system terminal itself. Next, we move to the figure 2, which is the main components in subsystem in nanoscale satellite. Actually, it consists of 3 subsystems, which is ground system terminal itself, the communication system, and the other thing is the sensor, main computer, navigation system there. So as you can see, the camera is the external thing. If you want to use the camera in the project, you can use it, or you also can to not to use the camera. Right, okay, next, in the figure 3, it is the sequences of the operation of nanoscale satellite where, first of all, we will turn on the system in the nanoscale satellite before we drop the nanoscale satellite in the height of 200 meter from the ground, above the ground. Okay, after we drop the nanoscale satellite, right? The ground system terminal will receive the data from the payload subsystem, and it will show all the data that the payload subsystem have, and it will be like that how the function will work. Next, we move to the methodology. All right, this is the communication subsystem design for my project where it consists of battery, voltage regulator. As you can see, there will be Raspberry Pi Zero, wireless, BME2X0, and also camera. Okay, this is just only the 3D design for the nanoscale satellite. Right, as you can see, we move to the next because I will share the same thing, which is this is the material. Right, next we move to the materials part, which is in the subsystem communication. I use 3DR radio telemetry kit. It is a communication between the ground system terminal and the nanoscale satellite itself. I use a frequency of 433 MHz. For the hardware, I use Raspberry Pi Zero wireless because it provides the Wi-Fi, and also it can connect to the Wi-Fi and Bluetooth, so I can connect the sensor of the sensor to the Wi-Fi. For the FEM 2.8 flight controller, it is a very ground system terminal user-friendly because it's provide the software as well, which is the Arduino Pilot Mission Planner. So I don't have to worry about the data because it will it will be shown in the Arduino pilot mission planner. Right. However, for the PM2.8 flight controller here, I will connect with the U-Blox Neo 6M to get the GPS location of the nanoscale satellite. For the sensor, I use BMP180 and BME280, which is both of these are the barometer sensor to collect the data such as the pressure data, humidity data, and also the temperature data. Alright, for these two sensors, okay, the data will be shown in the JSON viewer. So I will use the JSON viewer as well. Right, next I will show you how the nanoscale satellite itself. Okay, as you can see, this is the antenna, or we call it the duck antenna. It's a set of the 3DR radio telemetry kit, and this is the GPS sensor U-Blox 6M. Right, this is the in the side view for the for the camera, I will put camera over here. As you can see, this camera will provide the live view. If we drop the nanoscale satellite, we provide the live view of the during the launching. Alright, as you can in the left side, this is the live view, live stream view for the Kansai satellite, the nanoscale satellite being dropped. And at the right side, this is the data from the JSON viewer. So it will keep refresh the data every 5 seconds interval. So and here you can see the pressure data, the humidity data, and the temperature data. Okay. So you can see that. Alright, it will be dropped at the certain height. The location is at block P. So you can see the GPS here. The data keep changing. Alright. As you can see at the pressure data, based on the barometric law, the pressure in the atmosphere decrease as the altitude increase. However, in here we can see that the data collected by the pressure show the differently. This is due to the time taken the time taken to collect the data and the wind condition as well. As you can see, it is unstable, right? Okay, I can conclude that is the one of the reason. And the time taken is very short. It's not even 5 seconds. Almost, it's not even 10 seconds. I can say that. That is why the data keep changing rapidly like this. Right, and as you can see in the humidity and the temperature data, the relationship between the humidity, temperature, and altitude is when the temperature increases, the more water molecules can be retained, and its relative humidity will be decreased. Relative humidity rises as the temperature drops. As the temperature exceeds the dew points, the value high humidity exists. Thus, the temperature affects the amount of humidity and also the atmosphere. Okay, as you can see the figure, these two both figure shows that the humidity decrease and the temperature increase, and also the altitude also decreases. This means the hypothesis that I said is proven because it can show by the data here. The conclusion for my project, I can say that the Arduino Pilot Mission Planner software successfully shows the data that I wanted, which is the altitude, speed, and also the GPS location of the nanoscale satellite in the ground system terminal without any interference and without any problems. The collected data are shown in the ground system terminal will be shown when I own the nanoscale satellite system, and also the pallet subsystem itself collects the temperature, humidity, and the pressure data, and shows that the data through the JSON viewer, and the JSON viewer keep refreshing the data page every 5 seconds interval. So from there I can get the data. I can conclude that I achieved the objectives that I want because I built the system, the affordable system, and also the user friendly, and it is very suitable for the new user for me, so I can learn new things from the nanoscale satellite system itself and also the ground system terminal itself. For the reference, this is one of the references that I use, which is I got it from the CANSAT manual CANSAT textbook. It is in PDF, and also I read thoroughly in the this article, which is consideration about an UAV command and control ground control station. And I mean, these the three things the three things references are very meaningful to me because from there I get the knowledge, and from there I know how to build the nanoscale satellite and also the ground system terminal, how it works and how the sensor will be functioned. Right, that's it from me. Thank you so much.